Hello everyone. In today's video, we are going to discuss classifying real numbers. Our learning target for today is I can classify real numbers. So you're probably asking, what is a real number? Well, every number that you've experienced so far in math is what we call a real number. Real numbers are numbers that we use to measure one-dimensional quantities such as distance, duration, or temperature. Now, within the set of real numbers, there are subsets of different types of numbers. Those subsets include natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Looking at each of those subsets a little bit more directly, we can define and give examples of them. So the first subset is natural numbers. Natural numbers is the set of all positive counting numbers, so numbers on a number line, that start with 1. So some examples would be 42, or 50 divided by 2, which is 25, or 800. My next set is whole numbers. So whole numbers is the set of all positive counting numbers starting with 0. So I could have the square root of 100, which is 10, 0, or 4 plus the square root of 4. Because the square root of 4 is 2, so 4 plus 2 would be 6. After whole numbers, my next set is integers. So integers is the set of whole numbers and their opposites. So some examples of integers would be negative 15 over 3 because that's negative 5, 25, or negative the square root of 81 because the square root of 81 is 9, and that would be negative 9. After integers, my next set is rational numbers. So rational numbers are numbers that can be written as fractions. They're terminating decimals, repeating decimals, and perfect squares. Some examples of rational numbers could include 12 and 5 sevenths, negative 6.8, and 5. And then my last set is irrational numbers, or numbers that cannot be written as fractions, and non terminating decimals, non repeating decimals, and non perfect squares. Some examples of irrational numbers could include 3 pi, square root of 10, and 6.7234 dot dot dot. Remember, those three dots tell me the number will go on forever. Now, if I want to specifically classify these numbers into different sets, I can think of my entire set of real numbers as a Venn diagram, where within the Venn diagram, I will work from the smallest box to the largest box. So my smallest box is my set of natural numbers. Then my next smallest box is the set of whole numbers. Then my next box is integers. Then my next box is rational numbers. And then the box on the right is irrational numbers. Now, the way the Venn diagram works is if you're in the smallest box, if you're a natural number, you would also be a whole number, you would also be an integer, you would also be a rational number, and you would also be in the entire set of real numbers. Also notice if you're an irrational number, you're not a natural number or a whole number or an integer or a rational, but you are in the set of real numbers. So looking at these numbers that I have, 2 root 64, negative 15, 16 divided by 4, root 75, 0, and negative 12.2, I can classify them as these different sets. In order to do so, I need to know exactly what some of these numbers are. So 2 square root 64 would be 16 because the square root of 64 is 8. 8 times 2 is 16. Negative 15 is obviously negative 15. 16 divided by 4 is 4. The square root of 75 is okay. 0 is okay. And negative 12.2 is okay. So let's look at these numbers and place them in their appropriate box. So 2 square root 64 we know is 16. 16 is a natural number. So 2 root 64 goes in my natural box. Negative 15 is an integer. So that goes in the integer box. 16 over 4 is 4. 4 is a natural number, so 16 over 4 goes in the natural box. My next number, root 75. I know any non-perfect square is irrational, so square root of 75 goes in the irrational box. My next number, 0, is a whole number that will go in my whole box. And my last number, negative 12.2, is a rational number because it's a decimal, and natural, whole, and integer numbers do not include decimals. And it's a terminating decimal, therefore it's rational. So this is how I would classify all these numbers. My natural numbers are 2 root 64 and 16 over 4. Notice that if you're a natural number, you're also a whole number, you're also an integer, and you're also a rational number. My set of whole numbers was 2 root 64, 16 over 4, and 0. Then my set of integers was 2 root 64, 16 over 4, 0, and negative 15. My set of rational numbers was 2 root 64, 16 over 4, 0, negative 15, and negative 12.2. And lastly, the only irrational number that we had was the square root of 75. In this lesson, we learned when classifying real numbers, determine the subsets that the real number belongs to. Natural numbers are the set of all positive counting numbers starting with 1. Whole numbers are the set of all positive counting numbers starting with 0. Integers are the set of whole numbers and their opposites. Rational numbers can be written as fractions and include terminating and repeating decimals and perfect squares. And irrational numbers cannot be written as fractions and include non terminating decimals, non repeating decimals, and non perfect squares. That's a wrap on this video. We'll see you in the next one.